Unit 10B, normal distribution. Given an area, find an associated raw score. The heights of pea plants are normally distributed with mean 20 inches and standard deviation 4 inches. What is the 80th percentile pea plant height? When you have a problem and it says the distribution is normally distributed, the first step is to draw the bell curve. It might be useful to make the picture where you indicate where the mean is. The mean is always going to be in the center of this symmetric curve. The mean is 20 inches. The standard deviation is 4. I put that out here. And we're looking for the 80th percentile. If you see percentile or percent or probability, we should associate that with area under the curve. So we're looking for the 80th percentile pea plant height. We're looking for a certain area. Now, where is that area? If I put in another line for percentiles, in the middle is the 50th percentile. That means 20 is the 50th percentile score. It's higher than 50% of the distribution. The 80th percentile score would be higher. And this is the score we're trying to find, the 80th percentile score. That means that this score is in the 80th percentile. It's higher than 80% of the scores in the distribution. So we're trying to find the 80th percentile score. We can use the TI-84 to do this. The TI-84 has a built-in function called the inverse norm. And what you do for the inverse norm is put in an area below the score you want, mu and sigma, and that will give you the raw score. So in this case, we would use the inverse norm. We're looking for this value of x right here. What is the area below it? The area to the left below it is 80%, so you would put that in as 0.80 into the calculator. Then mu would be 20. Sigma is 4. Press enter, and you will be given the raw score. So on the TI-84, it's second distribution, and then you choose number 3, which is the inverse norm function. Into that function, you put in the area, which is 0.80, or in this case, 0.8. The mu was 20, standard deviation 4. Navigate down to paste, press enter, and you'll be given the raw score that we're looking for. We could round that off to approximately 23.37 or 23.4. We could also do the problem by hand using the normal distribution table. The normal distribution table has a structure of this form, where you have z-scores out here in the margin and areas in the body of the table. So it relates z-scores with areas. And in most tables, it's areas below the z-score. So we are given an area below this particular raw score, and the table allows us to either change an area below to a z-score or vice versa, change a z-score to a area below. We'll have to change this area to a z-score and then change the z-score to a raw score using a formula, x equal mu plus sigma z. So here's our standard normal distribution table. In the body of the table, we have the areas. Notice the areas all have 4 decimal places. So we'll want to take our area and make it 4 decimal places, 0.8000. Out here in the margins, we have the z-scores. So in this case, we look up 0.8000. Let's disregard the point for now. We're looking for 8,000. Well, the numbers start here at 5,000. As you go down, you'll see they get larger, and you're looking for 8,000, but you don't find it. What you find is 79.95, which is too small, or 80.23, which is too big. We want to see which of those is closer to 8,000. So 8,000 minus 79.95 is 5 units away, and 80.23 minus 8,000 is 23 units away. So therefore, 0.7995 is the closer of the two to 8,000, and it corresponds to, go across this row and up this column, and that tells you that the z-score that we want is 0.84. So we just found our z-score to be 0.84. Now to find this x we're looking for, we use the formula x equals mu plus sigma z. Mu is 20, sigma is 4, and z is 0.84. 4 times 0.84 is 3.36. So therefore x is equal to 23.36. Now this number may not match precisely with what you had on the calculator. The calculator carries more decimal places, and the table rounds off to 4 decimal places for areas. We can check our answer by using the empirical rule. If we take 1 standard deviation above the mean, 4 above 20 is 24, then we know that the area between 20 and 24 is 34%. And similarly, the area on the left half of the curve is 50%. 50 plus 34 is 84%. So therefore, the area below 24 would be 84%. Now we calculated a number here of 23.4, and what does the area below 23.4 look like? Well, that would be this area, and this red area looks like it's a little less than 84%, and so it's reasonable to say that it could be about 80%, and that verifies the answer that we got. This is the end of Unit 10B. See Unit 10C for the central limit theorem.